Okay, in this video we're going to review working with derivatives of inverse trig functions. So I'm going to derive one, show you how it comes about, and then I'm just going to state for you the derivatives of the other inverse trig functions. So the one we want to look at here is the inverse sine. Now there's two ways to write your inverse trig functions. There's the more calculus way, and then there's the more pre-calculus way. I'll use both. Our textbook does use the inverse, the -1 notation. So I'll try to use both of them, but I really, a long time ago, got in the habit of calling it arc sine instead of inverse sine. It's the same thing, but just be aware that arc is just another notation for inverse. And you'll probably see me use them both ways. So to do the derivative of an inverse trig function, we first write the relationship down as y equals arc sine of x. We then use the inverse condition to rewrite the equation as sine of y, so we apply basically a sine to both sides, equals x, right? If y is the arc sine of x, then sine of y is equal to x, right? Because arc sine tells you the angle that you need to apply sine to get x. So if we apply sine to y, we should get x. Then what we do is we take this equation now, and we're going to differentiate it with respect to x. Because that's what we want, the original derivative with respect to x. So when we do that, remember implicit differentiation. When we do derivative of sine y with respect to x, well, we'll do the derivative of sine, which would be cosine y. But then that's multiplied by the derivative of y with respect to x. So either dy dx, or as I like to write it, shorthand, y prime. And then on the other side, we do the derivative of the x there, which is just 1. And so we can solve and get y prime is equal to 1 over the cosine of y. But unfortunately, that answer is in terms of the variable y, not in terms of the variable x. So we need to actually compute what amounts to the cosine of the arc sine of x. Now, the way we do that is we actually look at this relationship here, y equals arc sine of x, right? Y equals arc sine of x, and sine y equals x. We use this relationship to draw a picture from which we can compute cosine of y. Okay, so that's what we're going to do here. So we go back and we draw a picture. We know that arc sine is defined in either the first or the second quadrant. So when I draw this picture for sine of y equals x, I'm going to draw an angle in either the first or the fourth quadrants. Now, as far as cosine is concerned, it doesn't matter to cosine, because cosine is positive in both the first and the fourth quadrants. And so therefore, cosine doesn't really care where I put it. So for simplicity, I'm going to draw my angle in the first quadrant. So this is my angle y, and we know sine of y is equal to x. So using my reference triangle here, my right triangle, for the angle y, sine of y over here is equal to x. Sine is opposite over hypotenuse. So this will be x over 1. And now we know two sides of my right triangle. To compute cosine of y, I would need the adjacent side. And I would take the adjacent side over the hypotenuse. So we just need to figure out the adjacent side now. Well, for the moment, let's call that A. For the moment, let's call that A. And then we use the fact that we know the other two sides of this triangle to work out what A will be. And that would be A squared plus X squared equals 1. Right? So we bring the X squared over and take a square root. Now, A is on the positive x-axis, so when we do square root, normally be plus or minus, but now we're going to do just the positive one because it's positive. We'll have A equals the square root of 1 minus x squared. Okay, square root of 1 minus x squared. That's what A is. And so now we know that our derivative, y prime, which was the derivative of the arc sine, is 1 over cosine y. But we can now compute cosine y in our picture because we now know what A is and we know the hypotenuse is 1. So putting that all together, the derivative of the arc sine, of x is 1 over cosine of y, 1 over the square root of 1 minus x squared. So now we have derived the derivative for arc sine. In a similar fashion, you can develop the derivative rules for the other 5 inverse trig functions. But I'm just going to give those to you here as a list at the end of the video. And then you can copy those down. And so now, as if by magic, we have them all written up here. I wrote them here in terms of u. So that's kind of giving us a little shortcut on the chain rule. So it's always the derivative of the inside function over 1 minus the inside function squared. What you want to notice here is there's 6 of them, but they're actually a lot easier to remember because there's really only 3 rules. Because all of the cofunctions are negative. So if you know the derivatives for arc sine, tangent, and secant, then you also know the derivatives for arc cosine, arc cotangent, and arc cosecant. One little piece of note here in the secant, yes, that is absolute value there. Okay, that is absolute value of u. So that's u prime, and then you have an absolute value of u and a square root of u squared minus 1. Okay, so these are going to come up right now as we review some more examples with the chain rule, and they're going to come up again later when we actually look for integrals that somewhat involve, in some way, an inverse trig function. So there's going to be what we're called trig substitutions and things that we'll be doing to handle those kind of expressions a little later.